Excellent.
Oh, hey, what's up, everybody? Welcome back to another 3D Hangouts. My name is Noah. I'm a designer here at Adafruit, and joining me every week is my brother Pedro.
Good morning, everybody. I'm Pedro S, Creative Tech here at Adafruit, and every week we're here to share 3D printed projects featuring electronics from Adafruit.
That's right. This is where we combine 3D printing and DIY electronics to make inspirational projects. Hello, everybody. Welcome to the show. We are hanging out in the Adafruit Discord server. Big shout out to everybody hanging out there. If you'd like to ask any questions throughout the show, that's where you can do it. We'll also periodically look at the YouTube chat and the Facebook chat. Some of the other places like Twitch and things we might not be able to get to because we have too many tabs. But hey, hello everybody. We'll shout you out as people get in there. We're a little early because, well, things happen. Wirecast.
That's all you need to know.
Yeah,
Wirecast.
That's all you need to know. I got some fun banners. Let's start off with this one over here. So we're celebrating the 99th issue of the CircuitPython newsletter. It's really called Python on Hardware, but it's going to happen on 9/9, which is next week, CircuitPython Day. So there's lots of fun live events going on, a Spanish show and tell, and much, much more. Check out the blog for more info on the awesome happenings on CircuitPython Day next Wednesday.
Speaking of the Spanish show and tell, it's going to actually run during our time slot next week, so there will be no 3D Hangouts. Definitely tune in, though, at the same time to check out all the awesome things being shown off from around the world. So definitely stay tuned with the same time slot.
Yeah, cool. All right, the CircuitPython meeting will actually happen on CircuitPython Day, so that's going to happen on Wednesday at 2 p.m. Eastern Time. Again, that's Eastern Time, 2 p.m. Wednesday, 9/9, which is next Wednesday. Normally it happens on a Monday, but it's a great opportunity for folks from the community to come together, share what they're working on, what they want to work on, and get an insight into what the core devs are up to. So Adafruit Daily is where you can go, adafruitdaily.com, to see all the different newsletters that are out there. CircuitPython on Hardware, it's just Python on Hardware. Can we just call it the CircuitPython newsletter? It encompasses all Python on Hardware, which is why it's called that. We also have 3D printing, IoT Monthly, and more. So check those out, adafruitdaily.com. We have a week newsletter that's focused on new products that get added to the Adafruit shop. So if you just want to get that, you can go to adafruit.com/newsletter, and that will give you a link to the new newsletter. The newness there. Adafruit gift certificates are available, and really this is just queuing me up for the return of freebies. That's right, adafruit.com/free. You can check out all the new tiers that have returned, and there's a little secret that we'll let you know is maybe we're not allowed to tell them. If you haven't even
I thought she said yeah.
We can tell them?
I thought she
all right,
said
folks, if you don't see us next week, it's because we didn't get fired. It's because there's no show. There's the CircuitPython Day. For about, I think it's in between the $99 and the $200 freebie tier, there's $150. If you spend $150 at Adafruit, you get a free Stemma board. I hope I didn't
we got
spoil
a
it.
range of, what are my notes on that?
We have 50 Stemma boards. This is huge.
So there'll be 15 options. If you have an Adafruit account, make sure to create one so we can keep track of which ones you've been getting, and you'll get a different one each time. So have a bunch of awesome little Stemma board freebies to go along with your
15
order.
different options. That's so many different sensors, microcontroller. Oh my gosh. You'll get whatever that, and we'll make sure that it's random and that you don't get the same one each time. Excellent.
So this is a jumping off point for, where they're going to be featured a lot in John Park's new show.
Right to it. This happened yesterday. So this is John's new show, JP's Product Pick of the Week. It happens every Tuesday at 4 p.m. Eastern Time or 1 p.m. Pacific Time. And there's John, excited to start a new live stream here.
Yeah, each week he's going to be taking a look at one of the 50 plus. It's growing so many. All of the Stemma boards.
50 Stemma boards, and we have some fun Stemma projects demos that we'll share today in our show. Yeah, we're jumping all over the place. I think it's going pretty well. Again, if you want to chat with us during the show or any time, the 24/7 chat is open on Discord. The invite link for that is discord.gg/Adafruit.
Giving shout outs to everybody hanging out in the Discord. We got Arjit, we have Mark Gambler, we have Mr. Certainly, as always, Charles Beneford, and over on the YouTube chat we have Dean Werner and Raphael.
Hey,
We're
folks.
in the Twitch chat as well, and the Facebook, Periscope, I believe LinkedIn as well.
Wow.
So good morning, good evening, good afternoon, and as Arjit is saying, it is nighttime here in India.
Nice. Good evening. All right, cool. Is there anything else that I might have forgotten?
For housekeeping, I believe that's
it. Yeah.
Let's go ahead and jump into this week's awesome project.
Yay. Let's
we
go.
have another Kickstarter-inspired project.
Not a Kickstarter. It's,
well,
let's call them a campaign,
you know
the internet
what?
campaign stuff.
It's fine, since a lot of the Kickstarter projects use all Adafruit boards.
Maybe for prototyping, I would say so. So yeah, we got inspired by the BusyBox interruption sign as a project that we liked. And we've kind of already done this before, so we figured let's refresh it and make it snap fit, add some new CircuitPython-ness to it, and make it a little bit different. So what's really fun about this one is it has a snap fit cover, comes right off, doesn't need any screws. We have black LED acrylic for the faceplates, so we have this really nice way to slide the faceplate on and off so you can quickly change it out. In addition to the black LED acrylic, we have some vinyl here that we use in our vinyl cutter. It's a little pre-cut. And we cut this out. We use some transfer tape and applied it on here. It looks really, really nice. So we have different signs. I have the on-air one. This is all black LED acrylic, which is specifically designed for diffusing the LED lighting. So that's really nice. And then we have this busy one with some different vinyl. This is like some glittery black vinyl, which is pretty neat. So I thought I'd try that out too. And again, cut on our vinyl cutter. This is a little hacking one with a Hackaday logo there. Some matte black vinyl again, which slides in like that, so you can get a nice quality when you cut out of vinyl. I tried some different things like using the hologram vinyl, but it really depends on what kind of effect you want. If I put this on here, everything becomes a shade of this, so it doesn't quite look that way. So I thought I'd share that though. But yeah, that's sort of the gist of the project. So let's go ahead and take a look at some of the features. So yeah, you got your faceplates. Inside of it is the Feather NRF52840, which has some Bluetooth connectivity. But you don't have to. You could use a regular Feather M4 Express or even an M0 Express. And then for the battery, I just have it tacked here to the back of this frame, which happens to snap fit as well, like this. So that opens up there. And then that gives you the inside look into the frame, which is where the LED strips, the NeoPixel LED strips, are secured with some double-sided paper tape, which is also called Nitto tape. Really, really strong stuff. We got a wire here that's a ribbon cable that just connects these two strips together. And this is the low-density NeoPixel strip. So it's about $17 for a meter, and I think it's 30 LEDs per meter. So it's like $17 for like a nice reel of them. And then we have these PCB. This one PCB mount that gets secured to the frame with some standoffs. So that's pretty neat. The slide switch here is built into it, and it has some little bit of separation here so you get a nice feel for it when you want to turn it on and off. It's just wired into the enable and ground pin on the Feather, as that is a good way to turn off the 3-volt regulator. The NeoPixels, there's only 16 of them, which is why it's okay to run it off the 3-volt regulator and the 3-volt pin here on the Feather. But there you can see when it's animating. So this is using CircuitPython, the LED animation library, and to do animations like the comet, where these two strips are going back and forth, you don't have to share the data pin. You can actually set up an 8x2 grid or whatever grid using the Pixel Map Helper, which is a part of the library. It's really nice. But the parts are pretty thin and optimized really for kind of printing quickly with less material. And it doesn't need to be any thicker than it is, so they're really thin pieces and they print pretty quickly, which is really nice. I think the part that prints the longest is these faceplates. What's cool about the faceplates is you can print them out in different colors and get different effects. And you can see here they got the snaps on these edges here. And then there's these kind of like end stops here that keep the thing from sliding out. Also, there's a little fun part here. There's this little kind of extruded bar here, and what it does is it helps keep the faceplate from sliding out. So let me get the orientation correct. So another fun thing is all of these print without any support, which is magical. Oh, that looks great in white. Like, I printed that this morning. It takes about 3.5 hours to print just the faceplate because it's kind of the biggest piece. But yeah, it looks great in white. I think I'll keep it like that. The way I'm mounting it to the wall is with these Velcro strips from Command. They're 3M. They use the 3M adhesive, so you can like peel this off and it won't damage the paint on your wall, which is really great if you if you don't want to put holes in your wall or have some nasty residue that gets left over from sort of your traditional foam tape. So I really recommend using these Velcro things. So I just stick it on there. These are additional brackets that are elevated somewhat so that the backing here, you notice it's open. Like, why didn't you close that? It creates a really sweet backlighting effect when you mount this on your wall. So if you just have it flush on your wall, you're not going to get that nice lighting on the back there. So by having it elevated slightly and having the back open, kind of does two things. Gives you that lighting effect, and I'm not printing 2 or 3 or 4 hours for the back cover, because all of that right there would take 2 to 3 hours just to print. Also, there's some extra mounting holes here that look a lot like the picture frame slots. So if you don't want to use these mounts and you do want to have it flush on your wall, you just use those holes there. Yeah. That looks great. I love the vinyl. It's really great. And the black LED acrylic is just, this is the best. You turn it off and it still looks black. It's almost like hidden. It's like, where'd it go? When you turn it on, it's back on there.
For some vinyl puns,
Vinyl puns?
is final. To go boldly into the vinyl frontier. This is Mr. Certainly Bruce on the Discord.
You know what's funny? Like, the vinyl cutter and like cutting the acrylic was way easier than 3D printing. Like, my printer was all like,
we're having some, what is it?
God.
The I2C reading
issues,
problems
yeah.
on the print heads on the Ultimakers.
It might have, because like it needed to get lubed up, so that sounds right. We needed to lube up the printer, and that's why I was having I2C headaches. But that's not what we're here for. Yeah, I have notes. Can I walk through them? Let's walk through them. So yeah, the parts they print pretty quickly. I made sure they're not any thicker than they need to be. I talked about like surface area, and if you can not use so much surface area, print without it. Having holes in your kind of faceplates helps print it faster. Cool. All right, I think I covered all that. Yep. I used quite a bit of standoffs, which are these little guys here. I used a lot of them. I think I used like a dozen or so. But by using these standoffs, these are M25 black nylon standoffs. We have a kit in the Adafruit store. I love that kit because it has all the different heights and all the different male, female, male type standoffs. So you have a nice assortment of them. By using those, I was able to not use support material, because in order to get this shape, you kind of can't do that without using supports. So thankfully, the black nylon standoffs came to the rescue and made this design work without any supports. So that's awesome. I'm a big advocate of kind of your standoffs. And I kind of don't like printing standoffs because sometimes they aren't the strongest, and it depends on what type of PLA you're having. If you're using some kind of more cheaper, economical PLA, it might not print so well with standoffs. So having these nylon standoffs, they're tough, they're strong, and you can cut them, and they work really well. And I use the kit. Let's see what else. It's easy to install too. The holes are sort of bigger than M25, so that you can pass the screws through and just tighten in those things. So it makes the assembly much easier. I really like the acrylic, that it slides through the rails really cleanly, to the point where you can kind of make it fall out, which is kind of funny. But once this is on here, again, that this little bar here will go right over this and it won't allow it to slide out. Just kind of like a neat little thing there, so now it can't come out. Let's see.
Hey, that's a good idea.
I forgot to bring the thing, but the
Yeah, Yanni on the Discord is saying you could also engrave it if you want, if you don't want to do the vinyl.
That is a cool point. You can totally mill and engrave
you could do
the
another
acrylic.
really cool effect with that.
Yes, you
where
can.
You wouldn't need the vinyl. You'd have the LED from the bottom. And we've actually done a project like that where it is milled out. It's the CircuitPython little desk wooden sign.
Yeah. I think my battery's dying. Like, it's not changing the color.
Oh.
Yeah. You want to plug it in? Great thing. Because I've literally left it on like all night. I need a USB cable to recharge the battery. Yeah. Yeah, no, that's fine. We'll just leave it on like that.
Oh, you have a cable somewhere.
I did. I put it back
this
over
one?
here. No, I put it over here. This one. Yeah, so it lasts like for like 5 hours, but.
Oh no, I was gonna plug it in over here just in case that.
I think
problems.
it's okay. We'll see, but I think it's okay. So let's go ahead and plug it in. So you got easy access to the USB port, which is always an important
that was actually
thing.
planned, wasn't it? And then somebody was asking what feather board you're using for that.
Yeah, you could use any feather, as the feathers all have the same mounting holes. But for this one, I thought I'd use the NRF52840, the BLE capable board. We do have some BLE code, the color picker code, but it's not using the LED animation library because the LED animation library came after. So that might be something that we do as a V2, where we have these animations from that library will be able to be triggered through your phone or whatever BLE device you want to use. Yeah, cool. I had some other notes here. Let's see. Yeah, I mean, the assembly is pretty nice. It's easy to put it together and take it apart. And it's one of those assemblies where you can solder all of the components, wire everything, and then you can stuff it into the enclosure. Because a lot of the times you kind of have to solder and thread things through other holes and things. But this one allowed it to be very modular, which actually helped me document it, because then I was able to take it apart quickly. The only thing that's kind of I don't know, is the double stick tape. Maybe if I had some slots or something for the strips, that would avoid having to use tape, but that's fine. It's just tape. It's not a big deal. At least it's not glue. Yeah, but I like that the whole assembly is, you can take the electronics out and everything is still there.
Got some questions on the YouTube. Paul350Z is asking, can you tell me about how you made the different vinyl cards?
Yeah, sure. So in CAD, I designed the faceplate, and then I took an SVG, a DXF out of it. That way I can get like the right dimension for the acrylic, and then I brought it into, I think, Illustrator, Photoshop, and just drew out some text, did some compound paths, and brought it into the design studio in Cut's website. They have their own app. You bring it in, and then you tell it how you want it to cut.
Let's go ahead and jump into the learning guide, since there's a more detailed.
Yeah, there's a little bit more detail there. So yeah, good idea to jump in. All right. All right, the homepage just covers all the different parts that are used. You got the 30 strip LED, the black LED acrylic, the feather, the switch, battery. You can swap out the battery. I think any of the bigger batteries would fit too. Maybe the 2200 would probably be a better idea. Some of the other odd end bits is the M25 hardware kit. That's the black nylon standoffs I was chatting about. I also link here the acrylic cutter. It's a new tool that I got, and I recommend it. Real quick note, I was normally using my table jigsaw to cut the acrylic, but that's kind of messy and it can be kind of dangerous at points. So I recommend using the acrylic cutter scoring tool. That worked really well for me. I was able to do it inside, indoors, instead of having to be in the hot garage where my table saw is. Velcro strips are also cool for mounting. Clear vinyl paper tape, clear vinyl transfer paper tape. There's some on Amazon. It's a pretty good price. Matte black vinyl. There's also a nice roll of Oracle black matte vinyl you can get on Amazon. And then for scissors, we have these engineering scissors in the shop. So those are cool. All right. Moving on to the circuit. Pretty simple. Just two NeoPixel strips are daisy chained together via the D out and the D in pins. You just have 3 wired connections to the feather, 3 volts, ground, and whatever data pin. For this one, I'm using data pin number 6. And the switch is wired to enable and ground. You can have it powered via the USB port, or you can have that 3.7 LiPo battery plugged in directly to the JST port, which is what I have here. For the 3D printing, you got a couple parts. This is a nice little photo of the parts. They all print without any supports. Go crazy with the colors. For the CAD assembly, I have a little paragraph here on all the pieces, how they fit together, but you can just visually see them all coming together. For slicing, nothing special, just no supports. I'm using regular PLA. Yeah, like 10% infill, that sort of stuff. We have the NRF52840 PCB as a 3D model. If folks want to use that in their design, there's a link to it right here. And all the other CAD parts as well, like the switches and arcade buttons and what have you. Excuse me. The next page walks you through installing CircuitPython on your feather. It's a nice and thorough walkthrough with some screenshots. Ditto on the CircuitPython library bundle. You get that zip, and then you get access to all the different libraries. And then the next page, we'll talk about which libraries you actually need. You only need the LED animation library and the NeoPixel library. I got a screenshot of what the CircuitPy drive looks like when you plug it in to your computer with the USB cable. I got a Mu editor, is what we like. Just some text here on making sure that your CircuitPython is the latest and greatest. Here's the actual code. It's just a customized version of the example code that you'll find as a part of the LED animation library. This one's just tailored toward the effects that I like. So I got an 8x2 sort of grid here that allows the comet to go left and right properly. And right here we go. Yeah, and then you can change the number of pixels here in the NeoPixel setup. Here's setting up the LED animations. You can change the speeds, colors, and period of durations all here. They'll have their own kind of parameters that you can set up. And then when it comes to the order of what happens, you can adjust these LED sequences here in the LED sequence object. You can just change that out. And in the while loop, it's just running the animations. Pretty cool. You can change the interval here of your animations too, which is nice. I like kind of that global way to do it. Makes it nice. Yeah, I also like it even if you're just like doing basic colors. The LED animation lets you kind of name the colors as opposed to having to do the RGB values. So if you want purple, you just say, I want purple. Jade, you just say jade. It's pretty cool. All right, on to the acrylic cutting. So I got a little template that I think I forgot to upload. Oh my goodness. But I have it, and this is why we do the show live. So I'm going to throw up that SVG file as soon as the show's over so I can have that up there. But yeah, it's a SVG file. I'll probably also put a PDF so you can print it out on an 8x11 sheet of paper. You print that out, cut out the shape, layer it on top of your acrylic sheet, and that way you get an idea of where it is. I used a little marker to just mark lines where I needed to cut, and then I used the T-square with combination of a metal ruler to kind of score the paper with a hobby knife first. Once you get your initial score, then you can ditch the roller and just kind of run through the score over and over again, maybe a dozen or more times. Normally, when you get halfway through your material, then you're free to snap it. I put it on the edge of the table and just snap it right off, and it works pretty well. I've had some where the snap was like at an angle or like at a 45. You can just run it through the sander and then flatten it out that way if that is a problem. I did run into that, but it's because I didn't score all the way down to halfway point. I was getting lazy, but I did make up 3 of them. So with I think it's a 12x12 sheet of acrylic, right? Yeah, 12x12 inch sheet of acrylic. You can probably make like 4 or 5 panels, maybe more. I don't know. I should have looked. All right, so the vinyl decals, I will also throw up these files too. They're SVG files of the 3 different ones that I put together, just the Busy, the On-Air, and the Hacking one. But most vinyl cutters support native vector files, which is an SVG, so I will have those there. I'll also throw up the PDF of these specifics. So you have 2 files now. You got your template for the cutting out your acrylic, and then you have these vinyl decals. So those will be the 2 files that I need to upload. Applying transfer tape. That's how you transfer the vinyl onto a surface. So I used sort of the standard grip transfer tape. Don't use the super heavy grip because then you will have some problems. Though I did, however, with the glitter stuff, the standard grip paper tape did not work, so I did have to use the heavier stuff with this version of vinyl stuff. So if you know stuff about vinyl, that's, you probably already know that, but I thought I'd throw that out there. Yeah, so once, you start from the center, you get yourself a squeegee tool, and then knock out those air bubbles. Starting from the center and work your way outward, you can remove the paper tape, the transfer tape, along with your vinyl, and then apply it to your piece of acrylic. Make sure you clean the acrylic with some alcohol so that there's no dust and oils on the surface. I chose to put it on the matte surface that's like diffused. That's the surface that I used. There's on the back is a more glossy surface that's very reflective. You probably don't want to use that surface. And then you can remove the protective backing once you're all done applying your vinyl. Any questions on the vinyl? I kind of ran through it, but it's that's how it is. All right, on to the wiring. So it's not too much wiring. I'm wiring up the switch with a 2-wire ribbon cable. It's my favorite type of wire to work with, as it stays nice and neat and it's flexible and strong. So I wired that up to the slide switch, and then I cut up my NeoPixel strips. It's just 2 strips. Each one has 8 NeoPixels, so I just cut those up. And just make sure that you follow the arrows, the labeled arrows on the flexible PCB of your NeoPixel strip. They tend to have, the low density pixel strips tend to have labels on them. So you can just look at it and be like, okay, that's DN. That's where I'm starting. At the end of that first strip, I connect D out to the second strip's DN with those 3 connections. So I end up with this nice kind of little wired strip. It's also nice that I put the length of the wire, because that's kind of important, especially for this project. So once we get those wired up strips, we have our strips and our switch that get wired into the feather. This particular feather, the NRF5284, only has 1 ground pin, so we're going to have to share that ground pin. So be careful there. But once I got the switch wired into enable and ground, I plugged in the battery and tested that out, as I tend to do. And then I unplugged it and wired up the 3 wires from the strip, making sure that it's the data in pin going into pin 6, sharing the ground with the switch, and then the 3-volt pin gets the 5-volt pin from the NeoPixel strip. And then I test it out. After we test out our circuit, let's put everything together. I start off by putting together the standoffs for the PCB mount. So the PCB mount has these 4 M25 by 6mm female-to-female standoffs and about 8 of these M25 by 4mm long screws. So you get the handful there. This photo gives you an idea of where what orientation the standoffs get mounted to. The switch has this little built-in holder. You just press fit it in, insert it at an angle, and the little actuator kind of pokes through the other side. So once that's installed, we can fit the feather over those mounting holes, over the standoffs mounting holes, and then insert the remaining 4 screws into the top there. All feathers are kind of designed for M25 screws, so if you don't have those, definitely pick some up. But once that's put together, then we work on to the faceplate holder. The faceplate holder is the thing where the acrylic slides in and out of. That uses 6 standoffs and 6 screws. So really easy to install them. You just kind of put the scred through the hole and then twist on, finger tighten those standoffs, those 6 standoffs there. And just for reference the photo for the correct orientation, you can see here that the railing protrudes the opposite way of the standoffs. And if you were going to 3D print this without the standoffs, or the standoffs built into the design, you'd be looking at a lot of support material. There you go. So once that's installed, you can fit the PCB into the frame, and then kind of test fit how the switch kind of pokes through here. You got that whole little area here. I like that because it gives like the switch separation in it, so it gives you like a visual cue that it's like like it's especially there. I don't know. I think it looks cool. And it keeps it contained too. Like if I would have mounted the switch to the frame, then I'd have like this kind of awkward assembly where I have to, you know, anyway. What else is next? Oh yeah, so for installing the strips, I got this Nitto tape. It's double-sided paper tape. So I cut up some strips, not too many. You don't want to like permanently adhere it. Maybe you do, but I cut up the strips and added it in there. It's kind of a tight fitting in there. If I used mini skinny strips, I probably would have more room, but I like the kind of the standard 50/50 size NeoPixels because they are bigger. They give you more light. So I fit it in here where it made sense because the wiring is a little bit shorter here on the first strip, and then do the second strip on the opposite side. So there's no NeoPixels on the sides, just up and down, top and bottom of the frame. Before I installed the mounting hole, I made sure to kind of test out, make sure the strips still work. So they still work once you stick them into the frame inside. And then once that's done, then you can install, you kind of have to do it like in a sandwich. You have to kind of, you lay down the kind of acrylic holder, the faceplate holder down first with the standoffs facing up. And then you lay down the framing, line up those mounting holes, and then on top of that, you fit in the PCB mount. So all of these get sandwiched together, and then the last bits are the screws that adhere everything, that secure everything down. So that's all there in words, so you can kind of see that. A little bit difficult to document that, but that's fine. You can see in the photos the right orientations, so you can reference those photos. So the last steps is to install the battery. Just throw it in there. No. There's some mounting tack that I have here on the middle bar here of the back cover. So I just stick it on there. And I normally like to just do that because I think folks will have different batteries, and designing something for specific battery is nice, but in this one, it's more modular. You can change it out as you like. So yeah, the back cover just gets press fitted in. There is a right way and a wrong way to do it. Just make sure you look at the lips and make sure that it's not kind of crashing into the USB port on the feather. There's a little proper cutout on those snaps on the edges of the back cover so that it doesn't crash into the feather. The last things is I got these mounting brackets that are additional. You just put them in with 4 more screws. That way you can elevate it away from your wall if you want that lighting effect. If not, you don't need them. And then installing the faceplate, just slide it through the railing. Make sure you orient it right, however you like. And then the panel is the front cover is kind of the last thing you do, I guess. Bam, that's the whole assembly. Woohoo! Woohoo!
Paul350Z says, thank you for the vinyl info. Very helpful.
Sure. Excellent, yeah. I found cutting vinyl much more easier
even the Wi-Fi setup,
printing.
Right? Or actually, you didn't use the Wi-Fi.
Nah, I just plugged it
Cricket.
in. Yeah, the Cricket.
Yeah, that's usually the struggles with
it's
getting
so
that
quick.
To work.
It's like, oh man, this thing's done. Wow, it only took like less than a minute to cut.
Mm-hmm.
They're fairly small too. The faceplates aren't that big. They're fairly small. I don't know the inches. It was like 118 millimeters by 90 millimeters. Sorry, but you should be able to get quite a few of these panels out of that 12 by 12 sheet of acrylic. So,
people are digging
cool.
the black LED acrylic.
I love it, man. It's such great material.
We are out of stock, but you can click the notify me when they are back in stock. They are getting another shipment, so those should be in fairly soon.
Cool.
And then Mark is saying this is really similar to how he's lighting his 3D printed lithophanes.
Yeah.
Really nice case design. Oh, that could be a good idea. Make a case for like universal lithophane case for that. Be super cool.
Let's see, what am I doing wrong?
And then what else? Oh, we had Rolls was asking if we can make an on-air sign that connects to streaming services so they turn on automatically. I linked to the project that John Park did a couple weeks ago that does exactly that, although it's using the Matrix displays.
Right, that's going to be a
So
fun
there
one.
is code for that. You can check that out. I did link him to the Learn guide that has all of the guide for the assembly and all of the code you're going to need for all the APIs to interact with. I believe it was Zoom and Twitch and YouTube.
Yeah, that's going to be awesome.
So you can definitely implement that. Mix and match learning guides. And then I posted all of the links for all of the individual parts that you're going to need to set this up. All of the libraries for any CAD 3D models that you're going to need if you want to make your own design.
Yeah. Just playing with
And Staltech is saying, yeah, it would be cool to have Wi-Fi connectivity integration into something like the OBS.
Totally, yeah. We think we're going to do a V2 where it has more, ties into some APIs. Maybe Adafruit IO can do something. We can tie it into if this then that. It'd be cool to trigger it through your Adafruit IO dashboard. I think that'd be pretty interesting. And you should be. I think you can do that with the NRF52840. You would connect to your phone, and your phone is what has a MQTT set up to a feed on your Adafruit IO dashboard. So there's some options there. Yeah.
Let's see. All right, cool. Awesome project. This is something that went immediately into use.
Yeah,
with everybody being homeschooled and working from home for all this time.
Yeah. That's so funny. Yeah.
Definitely need to know when people are in meetings.
Right.
I don't think this will be the last of these type of projects. I think we're going to do a couple more different versions.
Sure, yeah.
Since we'll be doing home learning for a while.
For sure.
All right, let's go ahead and jump into this week's What Are We Working On?
Yay.
Or what are we prototyping?
What are we prototyping? Here we go. We got some fun demos here. It's all Stemma. Stemma and Lego. What's the deal with that?
Yeah, so Lego has been making some really cool announcements. I think it was last week they announced their partnership with IKEA. And that made me think, oh my God, they are becoming a standardized connection interface for physical objects.
I've seen it as such, yeah.
But now, they're now being into furniture, and if you follow Lego on any of the social medias, you can see that they have some teasers. I didn't check this morning, maybe they released it. Their next partnership is going to be with Levi's, so they're getting into the wearables. So connecting wearables. So it's a really nice interconnecting little, what is it?
I want my Lego hat. I want Lego studs on my bill. I saw that at one of the Brick Fests.
Yeah.
And yeah, I should have bought it.
So we love breadboards, but with the Stemmas, you don't need to solder anything. Everything has a nice connection with multiple ports on each side of board. So Lamar has been super busy converting all of our sensors into the Stemma.
Sensors, breakout screens.
Yeah.
Microcontrollers, yes.
Yeah, so everything's being converted over. We actually need to go through. It's actually what I'm probably going to do on next week when we have off, is go through and just get rid of all of the old sensor styles. So we have all the new Stemmas.
Refresh everything.
Yeah, refresh everything in terms of, clean everything out. So yeah, like you were saying, there's so many different, over 50 Stemma boards have been worked on. I think it's already gone up too. There's a bunch more in the works. So Lamar wanted some nice, easy ways, since we're not going to need breadboards as much. You can still use it, but it'd be a lot more easier to just lay these out on a bunch of Lego plates. So she requested a bunch of different sizes for all the different board sizes that we have.
Yeah.
So we have all these different Lego compatible connectors. So a couple of weeks ago, we made the Lego Busy sign.
Yes.
And the main focus of that one for me was making all of these feather compatible Lego base plates so they can stick onto boards. And yeah, now we're just going to extend that over to all of the Stemma boards.
Sure.
We're going to do a nice little overview video and release all of the different sizes, because there are quite a bit of different sizes for these. So you can do a nice little customization of laying these guys out. So one of the demos that we have here is for this time of flight sensor. So you can see there, it detects how far objects are away. In this case, it's the camera.
Right.
And everything is nicely laid out.
Yeah, look at
like that. So you can have a nice little arrangement, orientation of your board, so they're not just flopping around everywhere. So this one is for the
feather wing doubler. So
yeah.
this is a great way to get your feather and a feather wing in one spot with plenty of extra pins for soldering stuff.
Should probably make a tripler version as well.
Sure, yeah, we should. I do have a tripler up there.
Yeah, so John had the idea of just making these little pins, so you don't have to use any of the 2.5 screws. So
just press fit in there and stay
update
locked
these
in there. So this is the new OLED display as well. It's the Stemma OLED. It's using a different driver, so we don't have CircuitPython support yet. This is an Arduino demo, but it is running. So you got kind of two things here. You got that new OLED that has the Stemma input, and then the time of flight sensor has the Stemma input too.
Whoops.
So that's how it's. Oh, okay. That's how it's connected. And then the doubler is just connecting the feather wing to the feather M4.
Got it. So it's not just the tubes, but we also have the, where did I get my one? Oh, here it is. We have stud versions as well. So if you wanted to connect things on the bottom, we got you covered on that. We'll have every different type for all the boards on that.
Yeah, there's lots of different ways you want to pick it up.
There's so many different ways to arrange this. So if you wanted to have this together like that, you could definitely do that.
That's a LiPo pocket for the 500?
Yeah. So got this guy right here.
That's the 500.
Yeah,
so if you need portable, you got your 500 LiPo battery.
Pockets.
Great for feather. And then that has the snap-in bit, so you can keep everything secured.
Yeah. So that's going to be next week's project. That's what we're working on to get all of these different sized Stemma boards out.
Yeah, it's great to keep all your stuff together.
Yeah.
We might actually make a breadboard thing they can plug it into, huh?
I mean, you could get a standard base plate.
I mean, like a connector for the breadboard.
Oh, yeah.
That'd be fun.
And not only the Stemma boards, but as well as just the regular old Stemma and any
non-QT boards. So
the JST2 connectors too, the little smaller connectors. So like the PDM mic, it's not Stemma, but it still has the same sort of connector.
Yeah.
So didn't want to leave these guys out, so I have nice little tiny ones as well. Nice
That's
little
so tiny.
Tiny little pins on there. Connect on that.
So small.
With this tiny little PDM mic.
Yeah.
Super handy.
We still got the Stemma speaker to pull out. I don't know what the hell
Oh, you're right. That is the last one I need to make sure it just fits.
I'm going to rip it out of my Lego head.
And also a bunch of the little tiny components as well, like our favorite slide switch. So you can have that on your base plate as well. So you can create a whole circuit on Lego. And you can orient that around. Giant, tremendous help when we were laying out the text or trying to draw with an LED strip. And then we still got the ones from that project as well. The 2200 milliamp hour cylindrical batteries. So tons of different plate sizes for all of our boards. Excellent. So that will be next week. That is the prototyping.
Stemma, 50 Stemmas. I got this.
Grab them all out. There's so many freaking boards.
Them on the table.
I know, right? The GPS, the other OLED, the what's this one? The 1.3, right?
Yeah.
Yep, the 1.3 OLED. It's just a ton of these guys. Awesome.
Yeah, Stemma. That's this. That'll be next week's stuff.
And of course, all of these designs will be available too, so you can update the studs if you want to make like a funky design. Like there's a bunch of like hinges and things that Lego makes. You can update those to whatever the project is.
All right, let's jump into Community Makes this week. We got a time-lapse Tuesday. Every Tuesday we time-lapse a fun design from the community.
That's right.
This week it's a continuation of Halloween props as we get into the festive seasons.
Yeah, all the department stores are all getting all their Halloween decorations out.
And we only know that because we follow Spirit Halloween.
We
don't
even
go to
even
stores.
like Home Depot, Lowe's that are posting all of their awesome Halloween gets. Phil B has an awesome guide on comparing the very popular eyeball
Monster eyes.
Monster eyes. It was released last year. Looks like a lot of the department, or a lot of the big named prop stores took note and actually copied exact for pixel by pixel his eye code. So he has a nice write up on just some of the
He has a Learn Guide, yeah.
Learn Guide on just comparing how they did their code and how he did his code. So this week, like we were saying, is prop. What got me liking this was because it's curved and it's collapsible. So 3D Printing World has made a bunch of really cool retractable lightsabers, and
he kind of inspired all the collapsible dagger swords. Here's his original one. He did a lightsaber. He did a dual lightsaber. Tons of awesome collapsible swords. You see 3 different ones. So his name's on the thing, right? His name's the Quicksilver, the Quirky Silver. I think it goes by as his handle. Yeah. The Quicksilver, like the QSR. That's what that stands for. So this is what, printed in place? Or you print the pieces?
No, they're all individually printed. Since I think it might fuse if it's all in one piece. But yeah, that's what's super impressive about this, is that it's all a curved piece that collapses. There's no sharp edges on this, of course. Using the silk black PLA, and really like the way that this little cap goes on there. It's just a piece of filament that is holding it in place.
Oh, and that's neat.
Yeah. Although this silk black looks very pretty.
Yeah, it's
not the best in terms of the
strength, I guess.
The layer adhesion. Even if I print it hotter, it does have some problems. So that's why I'm not sitting here swinging it around. I'm scared that it's gonna break. But yeah, it's a nice. Should have used just regular black PLA, so I could sit here and start swinging it.
Or the glitter silver from Filamentum.
Yeah, I am going to reprint it since my child does want.
He wants to stab you.
Yeah. But again, for role-playing, cosplay, I can't think of what over to the larger screen so you can see it full-sized. Yeah, that's what the curvature is on it. And yeah, I don't know what cosplay would go with, but definitely matches something in terms of role-playing.
Prince of Persia or something?
Prince of Persia, yeah. Yeah, definitely a good one. But yeah, still super impressed by how that retracts and collapses. Yeah. Oh, that's so cool. It's impressive. So yeah, awesome job on getting the curvature to work with the tolerances on that. I didn't have to do any horizontal compensation.
Nice.
I did use spiral mode for all of the blades.
That's interesting, spiral mode. Just for the blades?
Yeah, just for the collapsible parts. This is just regular, the handle, or the hilt and the cap is just regular, non-spiralized.
Do you have any issues with adhering to the bed, like it gets knocked off or anything?
No, the orientation that he has it set off, definitely do it that way, which is going to be the smaller parts first, because all of the smaller parts have. Do I have one of the? No, I don't have
You have some sort of more surface area to adhere to the bed?
No, there's like a little stopper that you can kind of see.
Right, it gives you more surface area, so it sticks better to the bed.
No, but you're printing on the smaller side, since it prints a stop, and that's the only way you can get the spiral mode to have that extra layer, unless you want to sit there and mess with like zero infill and your extrusion widths for your walls.
Extrusion width will help you, I guess. But, yeah.
But I've always had problems when I don't print it in spiral mode for these collapsible blades.
Yeah, it's just one perimeter? Wow.
Yeah. So again, super cool little prop. Caught my eye just because it's curved and it collapses.
And Halloween, it's coming up.
Yes.
Sweet. Well, it's free download off Thingiverse. You can grab it there. We'll have that linked, and the video went out yesterday.
Yes, definitely check that out. If you guys have any suggestions for Timelapse Tuesday, Community Makes,
drop them in the Discord.
At us on any of the socials. We'll see those. All right.
Yay.
Let's see. Going over our notes, I believe that is the show.
Yay. Yeah. Well, later tonight is show and tell. If you'd like to, we encourage you to come on and share what you're working on. The invite link to the StreamYard will get posted around 6:50ish p.m. Eastern Time, but it starts every Wednesday at 7 p.m. Eastern Time. It goes live on all the different channels: YouTube, Twitch, Periscope, etc. And then after, at 8 p.m. Eastern Time, is Ask an Engineer with Lamar and Phil. You get some new products, Python on hardware near the end, top secret stuff, and I think they'll talk more about the freebies, the new stuff, the Stemma stuff, and CircuitPython
from there. If you don't see it showing up, they did mention that it should be up no later than today, so probably before 7. So,
yeah, I'll keep refreshing the free page. Yeah. I hope there's a new
A lot of people like holding their orders too, so you can see all of the new stuff that's released during Ask an Engineer. I just keep my tab open on adafruit.com/new, and you can see all those start rolling in through the day. Every Wednesday, you can see all those popping up as the new products team posts that. A lot of cool new. A lot of cool newness already. Let me check that out.
Rainbow wire wrap. What's that?
Some tiny 30 gauge wire wrap.
Nice.
Yanni is saying one stemma to rule all stemmas.
Right. All right. And then tomorrow, don't forget John Park's workshop. He's still doing the workshop stream. Some live building, Make Code Minutes, and more. Check it out. John's workshop every Thursday at 4 p.m. Here we go. All right, and the last thing is this has been 3D Hangouts. We do this show every Wednesday at 11 a.m. Eastern Time. We appreciate you guys hanging out in the Discord chat room where you can chat with us.
Yes, we are all
Let us know our audio is still working.
Thank you all for that.
Yeah, we appreciate it. Cool. We're going to be on the show and tell later tonight. Talk more about the BusyBox. And until then, remember to make a great day. We'll see you guys later tonight.
See you tonight, folks.
Bye, everybody.
Bye.
Stay safe.